Hi, thank you for joining us to learn about the unique features of the Timbr knowledge graph. In this video, we'll show how Timbr users can easily perform hierarchical recursive SQL queries. Hierarchical queries can range from simple cases such as queries regarding a company and its subsidiary companies at the first level of hierarchy, to very complex queries about a company's subsidiaries and their subsidiaries with multiple levels of hierarchies. Timbr's transitive relationships enable users to write hierarchical recursive SQL queries without much effort because they eliminate the need for join and union commands. As a result, Timbr users significantly accelerate time to answer, and queries are easier to maintain and reuse. So let's see an example of how this works using a Crunch-based dataset. Crunch-based is a platform for finding information about investors, companies, and investments made. First, we modeled the Crunch-based data using business concepts enriched with relationships and logic. These concepts represent the data or classifications of the data with common business terms such as product, organization, IPO, funding round, and so on. Each concept is mapped to the relevant data in Crunchbase's dataset. After creating the knowledge graph, we can start querying the concepts just as if they were tables in our data source. The difference is that we leverage the semantic relationships to perform graph traversals that substitute the join and union commands. Our example query requires to show all the companies that were acquired by eBay directly, as well as all the companies that were acquired by companies which are owned by eBay. Without Timbr, this hierarchical SQL query can take a long time to define and write, as we will see shortly. Let's take a quick look at how easy it is to create a recursive relationship using Timbr. We'll begin by right-clicking on the concept we wish to create the relationship on, in this case, Concept Company, and select Edit Concept. In the window that appears, we'll click on the Relationship tab and create a new relationship by scrolling down and selecting New Relationship. Here, we have the option to create different types of relationships, such as one-to-many, many-to-many, and in our case, transitive relationships, also known as recursive relationships. We'll create a transitive many-to-many relationship, meaning we will be using an intermediary table to map to our relationship, as sometimes tables in our database do not represent an entity, but a relationship between two entities. We'll begin by choosing a many-to-many relationship and apply the transitive option by clicking the toggle on the right. Next, we will have the option to choose a specific transitivity depth that will appear in the metadata alongside our relationship when querying the data. We can also leave it as is, and the default level configured with the ontology will be in effect. In this example, we'll define a depth of 3. It's important to mention that although we choose 3 as the depth that will appear in the metadata, this does not limit the recursive levels of our query. At any point, we can choose to query depths above 3 as well by simply changing the depth number in the query, which I will demonstrate shortly. Now, we'll type the direct relationship name as well as the inverse relationship name. Semantics here matters, so users can understand the type of relationship. The direct relationship will be called has acquired, and the inverse relationship name will be called acquired by. Finally, we'll choose our target concept company, since this is a recursive relationship and points back to another company. We'll save the relationship and click to save the changes done to the concept. Now that the many-to-many transitive relationship has been created, the final step is to simply map our intermediary table to the relationship by right-clicking on our concept containing the relationship and clicking on Mappings. It's important to mention that if this was a one-to-many relationship, we wouldn't be required to add a mapping and we'd be able to skip this step. In the mapping window that appears, we'll click on Map Data. Next, we'll select the many-to-many mapping. Here, we'll choose the concept containing our relationship as well as the relationship itself that we wish to map our table to. Timbr now loaded the relationship information we defined earlier. We'll go ahead and choose the data source, schema, and table we wish to map to the relationship. Next, we'll match the concept's properties to the relevant table columns we are mapping from. For the source concept company, we'll match the property organization ID with the table column called acquiring object ID. And for the target concept, which in this case is also company, we'll match the property organization ID with the column called acquired object ID. Finally, we can choose to add additional properties to the relationship which can be used in the queries. For example, we'll add acquisition ID and created at which referred to the relationship and not necessarily to any company. We'll go ahead and save this mapping. And there we go. We're now ready to query using our relationship and put our relationship to test. To write our query, we enter Timbr's SQL editor. In the SQL editor, for this query, we choose the relevant model, schema, and concept in order to see the metadata containing the properties and relationships of the chosen concept. We'll add the transitivity relationship to our query directly from our metadata. In this query, we chose eBay as the object company, and we used 3 relationships. The first relationship shows the acquired company. The second relationship shows the transitivity level of the acquired company, meaning the acquisition level. And the third relationship shows the product that these acquired companies produce. We query the concept company specifically to see results regarding eBay. And we ask for our results to be presented in order of the hierarchical level. Please notice that in the parentheses of the relationship column, we added a *3 to set the maximum transitivity level to 3. This will return companies that were acquired up to 3 levels below eBay. So let's run the query. And there we have it. The resulting table shows companies that were directly bought by eBay with a hierarchy level of 1, as well as lower levels represented by 2 and 3. So for example, Venmo was acquired by a company that was acquired by another company, which was only then acquired by eBay, giving Venmo a hierarchical level of 3. Without Timbr, users wishing to add further hierarchical levels to the query would require to rewrite the query adding multiple join and union commands. With Timbr, this is done in seconds by simply changing the 3 after the star to any desired hierarchical level, for example 5. When we run the query now, we will get a table showing companies acquired by eBay down to the 5th level. By clicking on Explain Query, we appreciate Timbr's magic that transforms the 7 short lines of SQL into 103 lines of SQL that are pushed down to the database. Just like that, in a matter of minutes, users can deliver unique insights with ease, and these results can be exposed in any BI tool, web application, or data science notebook for further analysis. I hope you enjoyed this video. Contact us at Timbr AI for further information, and check out other interesting videos of Timbr's features in our YouTube channel. Thanks for watching and have a great day.